Hello everyone. In last video we have seen that lithium was showing the different properties different from the elements which are present in its own group. Their electronic configuration was same but they were showing the different properties and we call these properties as anomalous behavior of lithium. And in this video we will be learning the properties of some elements. We will be learning the elements, how they show the similarity between the properties of other elements, other group elements. Means the groups are made according to outermost shell configuration. If the configuration are different, we expect these elements to show the different properties, but some of the elements are there which show the relationship in their properties, means they show the same kind of properties just like the another group element. So let's see what these elements are. I'm Dr. Mary Kulshrestha and we'll continue with the S block element today. Let's start with the topic diagonal relationship between the element of one group with the element of the another group. So let's start doing it. So we have element from the first group, second group, 13th group and 14th group. And the diagonal relationship means this: lithium was showing the similarity in its properties with the magnesium, beryllium is showing the similarity with the aluminium, and boron was showing the properties with the just like of silicon. This is called diagonal relationship, and this diagonal relationship you can see here, this is between the second period element and the third period element with the next group. Okay, so this is called diagonal relationship. The reason is important here. Reason is that when we move from up to down, the size increases. This is the general trend in the periodic table. But when we move left to right, the size decreases. That is, when we move from left to right, the size decreases. And this increase and this decrease, if they are equal, what will happen? The size of this atom and the size of this atom becomes equal. And this is the reason that these elements which are kept in the different groups show the similarity in their properties. So this is called diagonal relationship. Diagonal relationship, the reason is the size, same, almost same size of these atoms. The size is same because the increase and the decrease will become equal in these cases, and just because the size becomes equal, the ionization enthalpy also becomes almost equal in all the cases, and rest of the properties which depends on the size, they also become almost similar in both these kind of elements. So we will be learning diagonal relationship today. We will be learning about diagonal relationship between the lithium and magnesium. Means we will see in what way, in what properties lithium is similar to that of magnesium, although both of them belong to the different group. Lithium अपने group के element के साथ similarity show नहीं कर रहा है, but it is showing the similarity with the element from the second group. That we will be understanding in what way, what are the properties in which it is similar to the magnesium. ठीक है, देखते हैं. So let's see the first point of similarity between the lithium and magnesium. Lithium and magnesium. The magnesium hydroxide, we know that it is a weak base. It is very famous by the name milk of magnesia, and we use it as an antacid. Same way, lithium hydroxide is also a weak base. We have learnt it in the last video that the hydroxides of the first group element, that is sodium hydroxide, potassium hydroxide, they all are strong bases. Lithium hydroxide was a weak base, but this property, being a weak base, is resembling with the property of lithium magnesium hydroxide. So this way they are showing the similarity in their properties. Both make weak hydroxide, weak bases. Next property, second property is, just like magnesium hydroxide is less soluble in water. Less soluble in water. Same way, lithium hydroxide is also less soluble in water. So their hydroxides are less soluble in the water. Jabki we know very well that the hydroxides of the first group elements are very highly soluble in water. Next similarity is that both of these oxides, that is magnesium form magnesium oxides, lithium form lithium oxides, both of them have no tendency to form peroxide and superoxide kind of oxides. So both these make only mono oxides. Just like magnesium, lithium also form only monoxide, जबकि उसके ग्रुप में other oxides like superoxide and peroxide were also formed. Fourth point of similarity is in the group of lithium, what was there? No other element was making a stable nitride, जबकि magnesium is forming a stable nitride, magnesium nitride. Same way lithium also form lithium nitride. So this is again a point of similarity. Another point of similarity is that magnesium nitrate MgNO3 hold twice. If I heat it, it will break down into MgO plus NO2 plus O2. Same way, if I break down LiNO3 lithium nitrate, this will also dissociate into Li2O plus NO2 plus O2. Can you see both of them are showing the similar kind of reaction. Both of them dissociate to give their oxide. On the other hand side, the nitrate of the first group element, that is if I break sodium nitrate, it will break down into MaNO2 and O2. So can you see the difference? There is a difference in the breaking pattern of the lithium nitrate and sodium nitrate, jabki magnesium nitrate is showing the similarity with the lithium nitrate, the breaking pattern of the lithium nitrate. So this is again a point where the lithium is resembling with the magnesium. Next and sixth point is that both of them have tendency to make the hydrated salts. Hydrated salts, we have already seen this, that lithium chloride exists as LiCl2H2O. Same way, magnesium chloride MgCl2 exists as MgCl2 8H2O. So this way, both of them exist as hydrates in their chlorides. So these form hydrated salts. So these are the properties in which lithium resembles with magnesium. The reason is the size of lithium to sodium increases this way, and the size from sodium to magnesium again decreases this way, because the size increases up to down, decreases left to right, and ultimately these two atoms which are diagonally related with each other, the increase becomes equal to the decrease to the right hand side. That is why the size of these elements become equal, and the property which depends on size becomes almost same kind of. This is the reason of the diagonal relationship between the elements of the one group to the elements of the another group. I hope this is clear to you. If you like this video, please hit the like button, share this and subscribe my channel also. In next video, we will be learning the trends which will be shown by the S block element, trends in the physical properties. So I hope this video will be helpful for you. Thank you very much.